about real math and what that means. Now, what I didn't just say was real world math. I said real math, and there's a little bit of a difference. I believe that math is figure-outable. That's actually my website, mathisfigureoutable.com. I know that's a little silly. But it is my huge message. And today I want to parse out a few things that I wonder can help us all know how math is figure-outable, maybe a little bit differently than we've thought in the past. So today I have two main objectives. I want to do something timely for now. I want you to leave today with something that you can actually okay, I can go mess with this in my classroom, I can think about this. But I also want to do something future a little bit to get you thinking about something that may be possible, a little bit of a vision idea. What might be something out further in your horizon that you can start to tinker with? So I have sort of those two goals. To do that, I want to talk a little bit about real math. But what is real math, and what would it be like to have a verb mathematize? What does that even mean? And then when we talk about teaching math, I wonder if we could consider changing the way we talk about teaching math to maybe more like mentoring mathematicians. If you think about the word mentor for a minute, that would sort of suggest that we would be mathematicians. Everybody stand up tall? Okay, don't stand up. Sit up tall. Could we consider ourselves mathematicians that are mentoring future mathematicians? Does that tweak or change a little bit how you consider thinking about, instead of teaching math, but really we're more about mentoring mathematicians? I want you to consider for just a second, I know I have some elementary folks in the room. You guys are sort of the master of all, right? Like I said, master of all. So you teach a lot of different things. I'm a former high school, so we have a lot of high school teachers in the room as well. We're a little stodgy. Elementary teachers are not. They're like still fun. Agree? Yeah? So you guys teach language arts. So what do you think for just a second, everybody, the last time that you took an English class, maybe it's the last time you took a good writing class. Like when someone was actually wanting to really, not a bad, don't think of a bad experience. Think of a really good experience when you were learning to write. Did you repeat, write over and over some lines that some old writer had written? Did you take Hemingway and just okay, this is how I'm going to learn to be a good writer. I'm going to take this passage that he wrote and I'm going to rewrite it. Do we just regurgitate writing to learn writing? Or, those of you who teach writing, do we write? Do we ask students to be writers? And then when they write, they come back to us and they say, all right, here's my writing for comment and review. And we read their writing and we mark on the writing and we say, oh, you might want to consider this. You might tell I'm a writer as well. When we teach writing, what we don't do is repeat or regurgitate or just spit back out what other writers have done. What we do is we write. So what would it be like for us to mathematize, maybe differently than we've done before? Now, I'm aware that in the room I have some different perspectives. That's right. We're going to talk about that in a second. First thing I want to do is maybe experience a little mathematizing. So, do we want kids to know their facts? Everyone go like this. Of course we want kids to know their facts. However, I want kids to more than know their facts. I want the facts at their fingertips, but I want relationships and connections. I want kids mathematizing the facts. So, for example, a most miss fact. If a kid is going to miss a fact, they might miss 7 times 8. That's a traditional most miss fact. So I might start with a problem like this with kids and say, hey guys, 7 times 8. I know a lot of you guys might not know that right off the bat. In fact, in a room full of teachers, anybody willing to admit, you don't actually know 7 times 8, but you refigure it fast enough every time that it's okay, nobody knows. Because you just do something real quick and, oh yeah, then I know. Anybody willing? In this room, I guarantee there's about, thank you for being willing. Do you guys see that? And those were only the brain ones. And they're not just the elementary teachers, secondary. So I know several secondary. In fact, I bet everybody in this room has a fact that you don't have memorized, that you don't just have at your fingertips, but you have a way to figure it out quick enough that you almost maybe have to admit to yourself, yeah, I guess that one I do have to refigure at a time. What I want to do is help students refigure sophisticatedly enough that it doesn't hamper them, that they can continue with math. So I might say something like, what do you know? Want to think about 7 8s or 8 7s? And then listen. And if the kid says, I want to think about 8 7s, then I might say, okay, so 8 times 7 I could represent with that array. But you want to think about 8 7s. Do you know 10 7s? If you want to think about 8 7s, do you know 10? Hey, 10 7s. 10. 10's nice, right? So if I know 10 7s, is that just 70? But I have an extra 2 7s. Can I get rid of that 14? Is that, hey, sure enough, that's 56. Now you might say to me, oh, subtraction, okay, then that's not your clue. That's not your relationship. Yeah. So then what do you want to think about? And then some of you might say, well, I want to think about 7/8. And I happen to know when I'm thinking about 7/8 that I know something about 5/8. I know 5/8. I just own that one. That one's sitting right there. And so I need 2 more 8s. Well, I know 2 8s. Oh, sweet nuts. Sure enough, those are also 56. Okay, that might be a fine word for you to think about. Somebody else might say, sometimes I want to think about 8 7s, but I happen to know, instead of thinking about all 8 7s at the first, I happen to know 4 7s. And so if I know 4 7s are 28, then I can just double those to get the 56. Now you might say, Pam, kids can't double 28. To which I say, some of them can. And if they can't, then start doubling with them. Like that would be a short routine that everyone in this room could do with your students. You could, when you have that 28 seconds left before the bell, right? Bell to bell. There's no downtime in math class. Do you have that 28 seconds before the bell? You're like, oh, what do we do? Hey, I know, let's double. Okay, guys, ready? Double 28. And then the kids fire back what it is, and then you say, how'd you do that? How'd you do that? How'd you do that? And you model their thinking. And then now, sure enough, soon enough, kids can all double 28. And this becomes a strategy that is accessible to more kids. I'm aware that I'm talking fast. I'm going to try to slow down slightly. Sarah took some of my time. It's okay. She's awesome. I really do think we could just listen to Sarah. That would be really great. All right, so I might start with a problem like that. Now notice that I'm just going to start with it. I'm going to say, do you know 7 times 8? You don't? Oh, guess what? Your job isn't to know it. Your job is to tell me what it is. What do you know? And figure it out from there. But figure it out in a sophisticated enough way that not only it doesn't hamper you from going on, but it also helps you learn higher math. Ooh, how would we do that? How about like this? Could 7 times 8 help you think about 70 times 8? Ooh, there's this cool thing with times 10, right? And maybe you can't describe it really well, but do you know that 70 times 8 is 560? Sure enough. If I know that 78 is 560, can that help me think about 69 eighths? Turn to the person next to you. Tell them what you're thinking right now. Go. Did anybody think about the fact that if we knew 78s, that we really just wanted to think about just 69 eighths, that we could get rid of that one little group of 8 down there? What is 560? Subtract 8. Is that just 552? Huh, interesting. I wonder if I were to ask you something like another most fact, like 6 times 9. Now, I might do the same thing where we talk about what do you know and how you can figure it out. But what is 6 times 9, everybody? And how many of you just refigured it in some way? Yeah, I bet you did. Okay, so if I know 6 times 9, does that can that help you think about 6 times 90? Is that just 540? Because if I scale this guy up times 10, and do I scale that one also up times 10? Can that also help me think about 6 times 89? Is indeed 89 sixes just one less 6? What is 540 minus 6? Is that just 534? Can you see how important partners of 10 could be in this case? Everybody was here yesterday. I'm not going to do that today. If you were here yesterday, we talked about partners of 10 and how important they are. That could have just come into play right there. If I've just done that series of problems, notice how we sort of did a helper problem to kind of help me with this one, and that one really helped me with that one. And then I did a helper problem to help me with that one that really helped me with that one. Ha ha ha, guess what? I'm a little unprepared. I did not come up with a helper problem for the next problem. Would y'all mind helping me? Oops, I'm in Minnesota. Would you guys mind helping me? Would you mind helping me think about, I'm sorry, you know, it was a little late and I'm playing, all these excuses. Could you help me come up with a helper problem to help me with that one? Turn your brief monitor on. This is a brief conversation with the partner next to you. Go. Did anybody come up with a helper problem like 8 times 6, which is that 48? And then 8 times 60, which is 480. And so what do we need? We just need one less 59. One less 60. One less 6? They're like, well, that's 8 already. How do I know? So now we're going to do some things with unitizing language to help students think about 68s. And if I can think about 68s, can that help me think about 59 eighths? Notice I'm not talking about 8 59s. We're talking about 59 eighths, and what is 480 subtract 8? So you just solved a fairly nice multiplication problem using thinking and reasoning that I can also say helps me think and reason about the single-digit facts. This is my point. I want to be able to think and reason about the single-digit facts in a way that helps me actually think and reason about real math, which the single-digit facts are a part of, and I'm really clear on that if I'm thinking about them similarly to the way we just thought about these guys. I would submit that in I have a short period of time today, so I'm only going to give you short examples today. But in a short example, this is an example of experiencing real math, or in other words, mathematizing. When you said to yourself, lazy presenter, what would be a helper problem? Let me think. Okay, and you came up with those helper problems, you were mathematizing. What you weren't doing is regurgitating some rote memorized thing. You weren't taking what some mathematician in the past has done and saying, okay, what's the first step? Wait, what was the second step? I don't remember what the second step. Let me look at my notes. What is it? Oh, the second. You were thinking to yourself, what relationship would help me here? And how can I use that to help me solve the problem? I submit that's a short example. The next part of my talk is going to be really shorter than I wish it was going to be. So I blog about this a lot. I would encourage you to go read some of what I've written about it, because this is going to be probably shorter than might be helpful for some folks. But I think I'm on the crux of something really important. I think there are three perspectives that we come, at least three perspectives, that we come at learning math from. And because of that, when we talk to each other, I think we talk past each other. I think there's a group of people in the room today that when we just did that, they're right now going, that's real math? That's your example of real math? Who is that chicker? Why did they bring up real math? That's like multiplication. Everyone does what she just did. I submit to you there's a group of people in the room that go, we all do that in our heads. Why is she drawing pictures? We all use those relationships. Weird. I mean, obviously for math people here, we all do that. So to that group of people, I say, actually not. At least not naturally without some help. But guess what? With active help, I can too. Because I was not the one who came up with it naturally. I was the one that you would say, just think like that. And I would go, what? And you would go, and then you would get frustrated with me and walk away. And I would go, whatever that was, okay, I'm just going to go back to rote memorizing math, because that's what I've been rewarded for. So I was the rote memorizer in the room, and I happened to do it well, and I got rewarded for winning around the world. I got rewarded for being the first to do long division. I'm sorry if that ticks anybody off, sorry. That was me. But honestly, that, now in hindsight, because I had the answer quickly, that actually hampered my mathematizing. Because nobody ever pushed me to think and reason. Because I was able to sort of spit back the teacher's work way too fast. So let me talk about these three perspectives. Here's the first one I want to talk about. Since we're sort of mathy, I'm going to call these the X's. Like variables, X, Y, Z. Okay, so these are the X group. Anybody see the movie? Yeah? Excellent movie. Highly recommend it. So I want you to think about how these three women had to have been sort of naturally decent at math. And the reason I say that, now I don't know them, I haven't interviewed them, but I'm guessing that they had some natural inclinations to make connections and relationships in their heads, because I'm just going to say they weren't having active help. Just at that period of time, I don't remember where you were, that we weren't really teaching math well. We were doing a lot of rote memory kind of stuff, we were doing a lot of rote regurgitation. Now maybe, I don't know, their personal circumstances, but based on where they ended up, I'm going to say they had some natural inclination. That no matter what, and I think there's a group of you out here today that I'm going to call the X's. Sometimes I call them A, B, C's. Then that kind of got grade oriented, so it's more like X, Y, Z, and it's not like grades. So I think there's a group of folks out here that when your teacher said, hey, memorize this traditional algorithm, you said, I guess I could, but for 69 times 8, I don't have to. I could just think about 7 times 8, 70 times 8, and then think about 1 less 8. Well, I know everybody in the room is doing that. Okay, so you watch the teacher say, thou shalt multiply this way, and in your head you started playing with numbers and making connections, and you assumed the rest of us did too. So I'm just here to say the rest of us did not. But we can. If you will put your brain on paper in such a way, like I just did, where I drew some arrays and the language that I used, then everybody can sort of latch on to that way of thing. We can all mathematize. So if you're in that group, I challenge you today to not look at what I'm doing and go, I don't know, what is this conversation even about? Like, the way we teach math is fine. I learned that way. So my kids can learn that way too. If they're like you, maybe. But I would also submit, as well as you learned it on your own, you could have learned more math better if you would have had somebody actively trying to teach you all the relationships that you were sort of naturally forming in your head. Because as many as you naturally formed in your head, there are more. And somebody could have helped you learn even more. So we could do that for the youths in the room. I think there's a second group in the room. Anybody see this movie? I'm dating myself a little bit. It's a little old. Stand and Deliver. This is about Jaime Escalante. This is not a cut on Jaime Escalante at all. But I'm going to take a moment from the movie and I'm going to point out something where I think the me's of the room. So this is my group. I'm going to call us the Z's. Like XYZ, we're the Z's. We are the rote memorizers of the room. Again, I'm not saying Jaime Escalante was, but in a moment in the movie, he does something. Okay, so the kid in the picture had just flipped him off. Not a nice thing to do. And so Jaime Escalante, this is a moment where we get to see his personality shine, and he goes, oh, finger man. You're gonna finger, all right, you're the finger man. Let me show you my fingers. And so then he holds up his fingers and he does the 9 thing. So you're familiar with the 9 trick? You might notice that I'm doing the 9, he's doing the 9 trick with his hands, palms out. I'm doing my 9 trick this way because it's sort of like almost flips you off a little bit, depending on, and that's my mnemonic way of helping you know how I think about the 9 trick. Is that legal to do? I don't know. So I'm not in favor of, get ready? Any trick. Because tricks are things that aren't transparent. That's not mathematizing. I don't want tricks. So I could memorize the 9 trick wrong. In fact, those of you who were here yesterday, sorry to keep referring to that, I'm only going to do this one last time. Kayla, that multiplied crazy, had the 9 trick down incorrectly. So every one of kids' multiplications by 9 could be really consistently wrong. Right? If you just memorize the stupid trick wrong. So I'm not about tricks. I think we can teach multiplication by 9 using the same sort of sense we just multiply anything by. If I'm thinking about 9 times 8, could I think about 10 eighths? But I only need 9 eighths. Could I just get rid of an 8? Can you see how I could think about anything times 9? That 9 trick, some people out there are going, but the 9 trick's really handy. For how many facts? Just for single digit ones. If I could get you to think about any 9s by thinking about 10 of them, and then getting rid of one of those groups, now I've got 9 times anything. Not just stuff that I can do on my fingers while I'm inadvertently flipping it anyway. So I think that's a trick, and I don't recommend tricks, but there's a group of us out here that think that math is all about rote memorizing stuff. I'm your poster child. I was the one who knew that I was being rewarded for getting correct answers when the teacher said, show me your work. The teacher really meant, show me my work. Right? The teacher meant, mimic me, and I will give you credit for mimicking my steps. Well, I just happened to do that well. Lots of my friends thought math was the same way, and they didn't memorize as well. They didn't go as far in math. What I'm suggesting is that that perspective is also a little bit, I was about to say faulty. Not faulty, but it has limitations. I want us all to understand where we're coming from, and then I'm going to suggest a solution. Ready? Here's our third group. So we have the X's that sort of are naturally inclined, making relationships, connections, could make more if someone was actively helping them. We could learn a whole lot if you were putting those on paper. We have the Z's, the me's of the world, who thought that, who believed the myth that math is about rote memorizing disconnected and isolated facts and procedures. Then we have the Y's of the world. So I'm going to introduce you to my daughter. I know this is a little personal. This is my daughter, Abby. She's a Y. Why do I use the letter Y? Because they always ask, why? So this is she's a little unique in some ways, but my daughter's dyslexic. I'm not saying that the Y's of the world are dyslexic. She happens to be. So she was a struggling reader. She had excellent teachers because I was working with my kids' teachers, and only the best teachers would take my kids. I'm not taking Pam's kids. No. Anyway, so they all had really good teachers until she hit 3rd grade. And she came home one day and she said, she had a weaker teacher. Came home one day and she said, Mom, I've always been really good at math and struggled in reading, and now I'm not good at math anymore. Mom went, why, honey? Control my emotions. What happened? She goes, I don't understand those little ones. She's like, all these little ones showing up everywhere. This doesn't make any sense to me. And my teacher's like, just do it. And she goes, just do what? Why are those ones showing up? So anybody have any idea? 3rd grade teachers? It was the first time someone had said, do this to add. This is the way you add multi-digit numbers. And so she would add the column of digits, and then this 1 would appear, right? She's like, I don't understand those ones. I said, honey, how are you? Now, she had an excellent 2nd grade teacher who had really taught her to think about numbers and use relationships among numbers. And I said, honey, how are you thinking about that? She said, well, I'm thinking about, so if the problem was, just remember I can write in this presentation. So if the problem was something like 234 and 199, she said, well, I'm thinking about 234. 99. Now, she was doing it kind of unsophisticatedly at this point. She was using second grade strategies. It was the third grade teacher's job to teach her third grade strategies, like get her more sophisticated. Third grade teacher wasn't doing that, so she just said, now do the algorithm. And she said, I don't understand where these ones are coming from. And I said, oh, okay, well, how are you thinking about it? Well, she was doing things like, if I just give 1 to that 99 and grab it from that pile, then I can think about 200 and 233. Mom, that makes a whole lot more sense to me. I'm like, sweetheart, you just keep doing that. And so I literally went to her teacher and I said, she'll do your math, she'll do your worksheet, your credit 4 million problem, add 50 million, but she'll do your worksheet. But she's going to do it her way, okay? And her teacher was like, okay. And she knew me well enough about campus. She's like, she bought it. She's like, okay, fine. A couple weeks later, or a couple days later, she came to me and she goes, Pam, it's taking her a lot longer. Now I kind of gave you a really nice strategy. Abby's strategies actually at the first were not that nice. They were a lot less, but bigger, smaller, fewer jumps. She might have done something like, okay, so 234, I'm going to add 100, and now I'm at 334, and so now I got to add 90. How do I do that? Well, maybe if I add 6, I can get to this friendly number. So again, her strategies weren't this sophisticated yet, but I knew I could get her there. And so I'm like, we'll do the work, don't worry about it. The teacher's like, she's kind of slow. And I'm like, don't worry, we'll get her there. By the time they were doing 3 add-ins with triple digits with all regrouping, Abby was wiping the floor with them. Because she just would do a little give and take, and was done with the problem, while all the other kids are doing all these regroupings and making all these mistakes. My point is, my daughter cannot do the math unless she understands it. I think we have a group of people out there, I call them the wise, who say, but why? And as a teacher, as the memorizer, I would go, yeah, it doesn't really matter. Just pick up your pencil and write that down. And they would go, but I don't know. And I'm like, pencil in your hand. And they're like, but if you could just, and I'm like, write the, because I knew that if they would just do it, for me, math was about these procedures to regurgitate. And so they would try, and they would try to mimic and whatever, and when they could, but when they could make sense of it, ooh, they could shine. So there's this group of folks out there that need to know the big picture and the why, and then they can as well. If we can help them see what's in that X group's brains, then we can all do real math really quickly. So she texted me the other day. So she's in 10th grade right now. And she said to me, this is me right now, wait, that rule doesn't make any sense, teach and other students. Well, that's just the way the rules are. That's how it works. Me, but that doesn't make sense. Why is it that way? Can you hear my daughter? This is totally my daughter. She's in Algebra 2. Did I mention that? Algebra 2. That's just how it is. And she goes, they expect us to mesmerize. Okay, remember, she's dyslexic. but that's actually kind of a cool twit, right? Mesmerize? Like, it's just, like, I think it means that to her. All these crazy rules that I understand, it's mesmerizing. It's like crazy. They expect me to mesmerize all these rules instead of understanding the reasoning through it. So I said, goodness, what's the topic today? Can you see where she responds right here? Logarithms. To which I went, oh yeah, that's probably not very figure-outable for your teacher. I bet your teacher has never figured out logs. I taught logs for years before I began to figure them out. Like literally, I just did the rules. So then a little bit later, she sent me a picture, and you can't see it, but there's all these logarithms on the board. She goes, when you subtract, divide, makes no sense. Logs are stupid. So my daughter. To which I responded, you make me smile, let's do all things log when you get home. Or maybe we're at the DPS, because we had to go get her license that day. She's almost 16, she can drive. Okay, anyway, so I think we have these 3 groups of people in the audience, and I think it hugely impacts. When I work with parents especially, and I do a lot of work with parents, parents will go, this is like, wow, why? How come? 2 questions. Why doesn't everyone teach this way? Second question, why haven't you changed the world yet? To which I'm kind of like, I'm trying. Give me some time. I think part of the answer is that we have these 3 groups of people. And I think that when we talk about math reform, the X's in the room go, we don't need to change anything. It worked for me. If it doesn't work for you, I guess you just don't have the math gene. I don't know why it doesn't work. And I'm not being snotty, but I really think this group of people doesn't understand what we don't understand. And that we could understand what you think we're all doing if you helped and put it on paper. I think there's a group of people in the room, and I think it's maybe the majority of teachers, and I'll show you why in just a second, who have bought into the myth that math is about rote memory. And so we are really good at helping kids rote memorize stuff. Like we sing and dance and rap and do all these cool picture things, and we do Dan Meyer's, like, get you excited about stuff so that then you're willing to try to memorize stuff. When in reality, we could just be learning the math. We could just be mathematizing. And I think there's a whole group out there that if we actually explained, we did real math, they could actually learn it. So I don't have time because I'm sort of running out of it, but there's some more people we can talk about, more stories, sorry. There's even some more, I ran out of time. All right, so if you were, this is a sort of less fun way of looking at those groups of people. So you can look at it either way. I would love to know who you are. Would you mind telling me which group you think you fall in, and would you mind doing it here? This is a quick little poll I have set up. Anybody willing? mathisfigureout.com/poll. That's my website. Now you'll have it on your phone. You don't have to do it. You can do it later. If you don't mind doing it, it's real quick. You're just going to answer, hey, on the web it says A, B, and C. A's were the X's. B's were the me's, the memorizers. Same order. C's were the Y group. Let's give you a second to do that. Can I keep talking to you? Well, that's a good question. Maybe more how you were learning math. Because if you're like me, now you know what real math is. Now you don't maybe belong in any of the groups. Maybe you're just a mathematician. So maybe sort of how you viewed learning math. Hey, this is the results I've gotten so far. When I've done this across the country and I've asked teachers who they are, I get an awful lot of memorizers. I get some folks that sort of naturally did some things, and I get a small group of Ys. I honor you if you're that Y group, because I think it was really hard for you to get here today. I think it was really difficult for you to fight through the, but why? And no one ever told you, and you made it to now you're teaching math. I own the fact that you made it. I think this is interesting, and I'm out for the next year. I'm collecting data across the country because I'm really curious to see if I can get people to go, oh, there are these three different perspectives, if I can begin to actually change the world. So who cares? I do, because I want to change the world.